In order to simplify a radical, we need to first know the parts of a radical. This symbol is called a radical symbol. The entire thing we can also refer to as a radical or a root. The little number that we see in the hook of the radical is called an index, and the number underneath is called a radicand. Now, if the index is not written, which typically with square roots we don't see the index written, then we automatically assume that that index is 2. That's why we don't see the index written on square roots. Now, the exponent divided by the index will help us simplify, like you'll see on the next page. We'll know that a radical expression is simplified when the index is as small as possible. We have no fractions underneath the radical and no radicals in the denominator. So to simplify our first radical, we'll need to do a factor tree for the 112. Things that multiply to be 112, we have 2 and 56. To multiply to be 56, we can do 2 and 28, then 4 and 7, and 2 and 2. The index here is 2. That index indicates how many have to be in a group in order for them to exit the radical. 2 need to be in the group. So here's a 2 that can come out, and here is another 2 that can come out of the radical. This 7 has to remain inside of the radical because it doesn't have a pair to come out. Now for the exponents for your variables, we could take and write out 7 different y's. That would be the prime factorization of y to the 7th. And then take and put them in groups of 2, meaning there are 3 that get to come out and 1 that remains. And that's not too terrible, for we have y to the 7th power. But if we had something like to the 18th power or even larger, that could get rather tedious. So the shorthand version would be to take the exponent, which in this case for the y is 7, and we're going to divide it by the index. This is going to be division like what you learned back in elementary school. 2 goes into 7 a total of 3 times, and we get to write remainders again. The remainder would be 1. Now the 3 indicates how many groups of y got to come out. Y to the 3rd came out. And the remainder is how many remain inside the radical. Y to the 1st remain inside. So there's our answer right across the top, right after we multiply that 2 times 2. So final answer would be 4y cubed times the square root of 7y. For number 2, this negative in front of the radical just means that my answer is going to be negative, and we need a factor tree for the 98. So for 98, we have 2 and 49, and then 7 and 7. The 7 can come out because the index is 2. I need 2 of them to come out. Remaining inside would be my 2. And to deal with the variables, we'll take their exponents. So in the u's case, it's 9 divided by the index, which is 2. 2 goes into 9 4 times with a remainder of 1. So u to the 4th comes out, and 1 of the u's remains. Then v to the 11th. So 11 is my exponent. My index is still 2. 2 goes into 11, a total of 5 times, with 1 remaining. So v to the 5th comes out, and 1 of my v's is still remaining underneath the radical. I do ask that you show me that work of division to the side, but there's not much more work beyond that to see. For number 3, we have an exponent of 8 divided by an index of 2. 2 goes into 8 4 times with no remainder. So y minus 6 to the 3rd power gets to come out. For number 4, we need to do a factor tree for our 32. So 8 and 4, 4 and 2, 2 and 2, 2 and 2. The index this time is 4, so I need 4 of the same number to be able to come out of the radical. 1, 2, 3, 4 2's get to come out of the radical. And I have a fourth root of 2 that has to remain inside the radical. For the variables, we have an exponent of 16 divided by the index of 4. 4 goes into 16 4 times with no remainder. So my g to the fourth gets to come out. For the other exponent, 23 divided by an index of 4. 4 goes into 23 5 times with 3 remaining. So k to the fifth comes out and 3 k's have to remain. Number 5, I have a square root of a negative number. We know that that means I'm going to have I in my answer. 24 needs a factor tree. 3 and 8, 4 and 2, 2 and 2. It's a square root, so I need 2 of the same number to come out and join the I. 3 and 2 will remain inside and be multiplied, so they'll become 6. Now for the y, we have an exponent of 5 and an index of 2. 2 goes into 5 twice with 1 remaining. So y squared will come out and 1y will remain. For number 6, we'll start off with a factor tree for 128. So 128 and 2 and 64, 8 and 8, 2 and 4, 2 and 4, and then the 8s or the 4s will go down to be 2 and 2 and 2 and 2. We are looking for groups of 6 of the same number. 1, 2, 3, 4, 5, 6. So one group of 2 can come out, and then we have the 6th root of 2 will remain inside. I see an exponent of 18 divided by the index of 6 goes in a total of 3 times with no remainder. So 2y plus 1 to the third power will come out with no remainder inside. For number 7, we need to make sure that we are not conditioned to just automatically see a radical and a negative and assume that an I is going to come out. If it's an odd index, then there is no I that comes out. Odd indices, when I take a root of an odd index, we can take just a negative out. So the cubed root of a negative number just has a negative for my answer. And then you can check 540 and see if it comes out nicely, but if it doesn't, we'll need a factor tree. So 54 and 10, 9 and 8, 2 and 4, 2 and 2. 9 would be 3 and 3, and 10 would be 2 and 5. It's an index of 3, so I need to have 3 of the same number to be able to come out. There's a set of 2's that gets to come out. And then remaining inside. Sorry, it's not 9 and 8. That's my bad. Should have been 9 and 6. My apologies. So we'll just back up a little bit to our factor tree. We have 9 and 6. Then 2 and 3. Much better. I'm looking for 3 of the same number. So 1, 2, 3. 3's get to come out. And remaining inside is 2 times 2, which is 4, times 5. So the cubed root of 20. Now, this is a good place to check, since I made that mistake, a good place to show you that you can check your answers on your calculator. So if I were to type into my calculator math and then option number 4, if I was using a bigger index, I would use option 5, but option 4 of negative 540, I get this long nasty decimal. I should get the same long nasty decimal if I type in what I simplified it to. Negative 3 times math, option 4, 20. Since I get the same decimal, I know that I've simplified it correctly. For number 8, remember we cannot have a fraction underneath the radical, so we'll separate these out into x to the 12th under the radical and 49 under the radical. So the square root of 49 is just 7, but for my x, I need to take the exponent and divide it by the index of 2, which goes in 6 times. So x to the 6th would be on top. For number 3, if you type in the cubed root of negative 27 into your calculator, you'd see that negative 3 is the answer, or you could have done a factor tree and didn't have any remainders. Then I need to check 15 divided by 3 goes in 5 times with no remainder, so z to the 5th. 18 divided by the index of 3 goes in 6 times with no remainder, so x to the 6th. There's my answer. For number 10, we know that the square root of 36 is just 6. And when I have an exponent that's smaller than my index, it automatically will stay inside. So a will have to stay inside here. Then I have an exponent of 4 and an index of 2. 2 goes into 4 twice, so b squared can come out, no remainder. And then I have c to the 5th, so 5 is my exponent, 2 is my index. 2 goes into 5 twice with 1 remainder, so c will come out to the 2nd power, and a c will remain inside. For number 11, if I type the cubed root of 125 into my calculator, I would get 5, or you could do a factor tree and see there's no remainder. Now the exponents, I need to do 6 divided by 3 goes in twice with no remainder, so t squared will get to come out and join the 5. Since 2 is already smaller than my index, w squared will remain inside. For number 10, we have the 4th root of 48. So a factor tree for 48, we could use 8 and 6, and 2 and 4, 2 and 2, then 2 and 3. We need 4 of the same number to be able to come out of the radical. There are 4 2's. Remaining inside of the 4th root will be the 3. The exponent is 8 for the v. The index is 4. 4 goes into 8 twice with no remainder, so v squared comes out with no remainder. Then 13 divided by 4 gives me 3. Sorry, 4 gives me 3. And there's a remainder of 1. So z cubed would come out, and a z would remain inside.